Welcome everybody. I think we're ready to get started. Hello, my name is Jim Deere. I'm the president of IMEROPEX. We're running this demo with a number of my partners. I'd like to introduce, Daniel, want to introduce yourself?
I'm Daniel. I'm with ShinyBox on the software side. I'll be picking up after Jim.
Sir? Can you introduce yourself?
Oh, sure. I'm Graham McKernan with Gal Media, and I work with Scott and Chris.
Okay.
Russell May with McKinney ISD.
James Parnell, Dallas Police. Rich Stotts, I'm Jim's board.
I'm Kevin Lawrence. I'm with the Texas Municipal Police Association.
Welcome.
Ray Hunt, Houston Police. Skylar Laws, I run this operation here at the Dome Lab.
Stephen McCandless, Superintendent in Cleveland ISD.
I'm Chief Allen from Cleveland ISD.
Welcome. Okay, can we have the next slide, Skylar? Sorry. Okay, so IMEROPEX is my business, but the service is called PEER. It's called Persistent Environment for Experimentation Rehearsal. And what we do is we use advanced VR, and you can see the VR complexity in the back there, and data science to recreate a crisis before it happens to determine what can be done to mitigate it before it occurs in the real world. But we also use the same approach, the same technology to do rehearsals. So experiment, rehearse. Find out what works and then rehearse against it. So it's much more than training. The training is an outcome of this. Next, please. So the purpose of the demo, first and foremost, is to get input from you. We have a QR code. We'll send the briefing to you at your request. The QR code will be published at the end. You can click on that code and provide your critique and comments on what you saw and how we build a better product. But the other thing is we're previewing, I am doing a pilot with Houston Community College in coordination with other school districts and other law enforcement agencies around the area to do this in much more detail, with much more complexity. The pilot would last about a week and a half. Planning would start probably in the February-March timeframe. We execute in June, July. And generating from that pilot, we'll pressure test everything, the technology, the VR and the data science, and make sure it's available and workable for our potential customers. And our customers will help us build it as we do it. So once it's done, it'll be something you want and need. So it's very much a collaborative effort. Next slide. So the VR, the data, the IT component, the VR component of it is what we call FDVU, Full Diverse Reality Unit. And the Full Diverse Reality Unit, and you see the officers in back equipped with all this stuff. It integrates haptics for the feeling of touch, a bodysuit for the feeling of pressure and pain throughout your body, a treadmill so you can move around realistically in the environment, and a headset for audio and visual sensations. So multiple sensations immersed in such a way that it's indistinguishable from the real world. And the reason we're doing that is when the operators participate in these events, they believe it's there. It's that close to the real world, borderline traumatic. The reason we're doing that is the more they believe they're there in the environment and the scenarios, the better the data coming from the event. It's critical. Next. And the other part of it is the data science. My data scientist, Izzy Kohler, is in Rochester, New York. She's building all the data science behind this. But the idea is we'll create an environment and then have experimental factors running behind the scenes that we coordinate with you. You tell us basically what you worry about. What do you think is going to make a difference? And then we, in fact, integrate it into the environment and use analytical techniques to determine if they, in fact, have an impact on the mission. So as the operators are participating in the scenario, we're collecting data to determine if that factor made a difference. A new technology, a new protocol, a new architecture of the school, a new safety mechanism, a new procedure, what have you. And we'll give you data that helps you make decisions instead of just opinions. So full diverse reality, the technology, and then the data science combined together. Next. So in this demo here you'll see today we'll have two officers, two humble independent school district police officers. They're also alert instructors, by the way. They are in full diverse reality, and they've just been in it for the last 5 or 6 hours. They were here yesterday for half a day and a few hours today. So they're getting acclimated to it, and they'll be fully immersed, engaging an active shooter And the active shooter will be represented by a non-player character. It'll be a virtual active shooter, and then we'll have virtual students and teachers. And the scenario happens very, very rapidly, but they'll be engaging these individuals in the crisis. The idea is mitigating the shooter threat. Next. So in the demo, we'll give an inkling of what it's going to look like in the real world when we do this actually for real. We do the pilot and we actually have the service ongoing. So we're going to represent scenarios with facial recognition in place and represent scenarios with shot detection in place. And we're going to show basically, at least in the demo, the impact of those two factors on casualties, fatalities, gunshots, and so on. But don't take the data away thinking we've made a decision based on the data. It's just as a representation of what data might look like. But that's what we're doing. And then we're generating, as I said, notional data in a dashboard that Daniel will go over after the scenario is over. Next. So these are my partners. I run IMEROPEX, and my partners are ShinyBox, Daniel, the VR developers, OmniSpace 360, the Dome environment you see. The Dome is going to be used, a critical component of what we do. So when we have operators in the scenarios, the stakeholders, the managers will be in the Dome observing what's going on. That's the way it's going to work, without having to wear the equipment. And then Humble ISD, of course, is participating, have an MOU to participate in the demo. Valiant Digital is doing our video production. They'll be producing a video of this. It'll be released sometime next month. And then Ion, of course, is hosting this here. Morphic is our web developer, and MaceVL is our hardware company. They're betting all the VR hardware that we use. I think, and that's a QR code you can use. We'll be happy to send this to you, but you can use that code to make critiques, comments on what we're doing so we can make a better product. I think that's it, Daniel.
Okay. I'm Daniel, I'm with ShinyBox. Good morning. Here shortly we're going to spin up the scenarios, and we're going to run through 3 scenarios to give a very quick view of a taste of what this system is. In the first scenario, officers will enter a school. It's a small school. It's sort of a small area of a school. And they have no information, only that a school shooting has happened. This is public facing, so we're not trying to traumatize anybody. We're not going to show any gore. We're not going to show any violence. When shootings have happened, the kids are going to go into classrooms and hunker down. The shooter is not going to shoot at kids. So I just want to manage the expectations there. This is for public consumption, so it's going to be very PG. But there will be a shooter in the school, and the officers will engage him. After the scenario, I'll talk a little bit about the behavior of the shooter, the AI. What you're seeing here is simulating a bunch of stuff. It's not smoke and mirrors. So I don't know what will happen in each scenario, as you guys will see. So the first scenario, there is no mitigation in place. The second scenario will have a shot detection system. So the officers are prompted at the beginning of the scenario. They know whereabouts in the school the last shot was fired. And because they've used this a bit now, they know the layout of the school, so they should be quicker at finding the shooter. Now, it doesn't guarantee the shooter's there. He could have shot, moved to another location, but it's some information they wouldn't otherwise have. The third scenario, the school has facial recognition software, a facial recognition system, which is detecting when somebody is in the campus who ought not to be. And so the officers are on site before any shooting has taken place. And you'll see in that scenario there are students milling around, teachers, and you'll see the shooting as it happens. But for now, I'm going to have the guys fire up the simulation. It'll take a moment. I'm going to take a seat, and I will commentate. Take a few moments. They're firing up the server, and both officers. There's going to be a picture-in-picture. So here we're taking off.
We're good, go.
Copy good, copy good!
So what has happened there, again, we're not showing anything. We freeze when the officer has neutralized the target. So here, we're simulating casualties by the shooter shooting at the door, behind which there are children. And after a certain number of shots, we're going to register casualties. So if they take too long to find him, it's going to do it's going to register casualties. They had to find him. They didn't know where he was. It was just them searching through. We're going to take a very short break between each of the scenarios, let the guys in the suits cool off. It's pretty hard work. They're sprinting around, they're running, it's very physical. And what I'll do is I'll field any questions if anybody has any at this point. I will talk a little bit here about the AI that's driving the shooter. The shooter in this scenario has 3 modes. To Jim's point, we're collecting data from this. So we don't want to have lots and lots of random variables polluting the data we're collecting. So the shooter only has 3 behaviors in this demo. They are passive, aggressive, or evasive. If they're aggressive, if they're shooting, they don't see an officer in their field of view, they're not going to hear the officers coming. But if they see an officer, they'll engage and preferably shoot at officers. If they are passive, when they see an officer, they drop the gun and surrender. And if they're evasive, when they see an officer, they'll run to a point of cover. Once they've reached that point, they'll decide whether they're going to engage the officers again or just that it's not worth it and they'll surrender. So that is running in the background here. The point of doing these scenarios is, again, the rehearsal Jim's talked to, but when we're trying to pull out data and we have random variables, such as the behavior of humans and shooters, one scenario won't do the trick. There's going to be noise there. So the idea is that we'll run these scenarios multiple times, and then what will happen is those spiky events will smooth out and we'll actually get real data on, does this mitigation really save time over 10 runs? Does this one save time over 10 runs? We can actually compare, to Jim's point, we're looking at facts, not opinions or feelings about it. I think we're ready for the next session. So I'm going to take my seat again. I'll comment. I think the guys are ready.
What's the ad for this scenario? What's the thing that's different?
Oh, the mitigation here is shot detection. So the officers are given a prompt. They know where the last shot was fired. That is not to say that's where the shooter is, but it gives them a bead. Now we have a small environment. That's more valuable as the school gets bigger, the simulated environment gets bigger.
5, 4, 3, 2, 1, go. Hey!
So the shooter's not responding. And they neutralized him. He was going to start shooting at he's not non-responsive to commands. He was going to start shooting in the door, which is our proxy for casualties. So here is an example of that kind of randomness, why we run multiple scenarios. Because we have shot detection, the officers are given a location where he is. They'll come into the nearest entrance, and he happened to be right there. If we were in the scenario again and again, the same scenario, you would see it would be different. And this goes to that point where we have to run enough scenarios to smooth out the information. The value of the officers doing this a few times now is that they have learned the layout of our school environment. So that shot detection system, they know what the thing is talking about. When they started this yesterday, they didn't know. And this speaks to some of the power of the future capability of this. When we have your campuses and we can put officers through this stuff, they're generating data, but they are also learning. If something happens, they already know what the layout of the environment is. They already know where they're going to go. If somebody's reported a particular location, it's not the first time they've set foot on that campus. They don't have to even ever go to the campus. Any questions at this point?
So when they engage the bad guy, then on the screen they disappear. Is that what is?
So what's happening here is, as soon as they shoot the officer, again, to make this PG, they can only shoot when their guns are on the officer, so they can't accidentally hit students. They're not going to hit teachers or anything, or each other. So as soon as they hit the person, the scenario ends for them.
Okay.
And so what we just saw is the snapshot. They leave the session. We saw just the last sort of state of the simulation. You saw the shooter going to shoot at the door. So this is in this version, again, it's just a demo. So the shooter is not responsive. He does not respond to instructions. He's completely belligerent. And yeah, we're not showing any of the aftermath. We just want to, they neutralized him, and then we're going to move on from there. Any other questions? Or?
I noticed that when you heard the shot, the suspect had not started raising his gun yet.
Yeah.
Officers disappear, then he starts raising. Are they seeing something a little bit different?
Yeah, so this is being broadcast, so we're a little bit behind what they're seeing, but also he's non-responsive. There's a gun in his hand, so as soon as he moves, they made the call. All right, so I'm going to take my. Right. Yes. Okay. So what you're going to see here is the shooting has not happened yet. The school in this simulation variable has a facial recognition system, so it knows somebody is on campus who ought not to be. So the shooting hasn't happened yet. The officers have entered into a random location. They've been given a description of the shooter, but there's a bunch of students here, a bunch of teachers, so they're now trying to locate that person, ideally before he starts shooting, but the shooting has already happened. You can just about hear these shots are happening now. We're following one of the officers, and looks like we've found the shooter. Okay. So as soon as this officer goes up to them and lays hands on them, the scenario ends. That is an apprehension. We're not showing cuffing or anything like that. So what happened here is the shooter was in the cafeteria, started shooting, we saw the kids fleeing. The teachers and the kids there, that's dynamic behavior. They run to the nearest room to them, they'll try and run away from the shooter. And the one officer covers the other one while the first officer went to lay hands on the shooter. So again, we run this scenario multiple times. You may be belligerent, maybe in a different location. So right, they're getting pretty good at this now. They're able to get right to the shooter. Any questions?
You mentioned
For that
something
scenario.
about, so the layouts of the school.
Mm-hmm.
Can this be taken to like our schools in Dallas?
Yes.
So where you go in and get the exact layout?
Yes.
So the officers can train, if they're assigned to that school,
Exactly.
gives them better training. I mean, Dallas is big. We've got a lot of schools, we've got a lot of stuff. So they couldn't all be experts about their school, but the ones that are assigned to it, they can go through this and go, this is my school,
Yep.
I can practice in my school.
Mm-hmm.
Okay, so then you have to go in and video and.
That's right. For the folks at home, the question is, can this be applied to any campus, any school? The answer is yes. And we have different ways of doing it. We can, if we get CAD layouts of the school, we can do it. We can send people in on a Saturday, take photos. We can quite realistically construct that environment. We can make it, extremely realistic. Once this kind of goes behind closed doors, the gloves are off, we can make this very realistic.
So can you just take architectural plans and go, I can
Yeah,
come off that?
if we have CAD plan, there's usually files that the architectural CAD files or smart architecture files that have the geometry, so it's not just the top-down or side views. The other thing we can do is there's a technique called photogrammetry. We can go in and take a bunch of photos and generate the geometry of the school just from taking a lot of photos on campus. A combination of all three is best, but yeah, it's software. So the beauty is, whatever your campus is, and if you're planning a change on the campus, you can add a bit and try that one. We can close off bits and bobs of the campus. We can simulate the grounds outside. So one of the operational variables we'll roll out in future versions is the officers don't have to come in through the doors. They can maybe go through the windows and come out through a classroom. So this is part of what Jim mentioned about working with you guys. What do you need to know? What are you wanting to test? What are you wanting to train your guys for? Yeah, we can do anything.
Are each one of these scenarios different for the officers over there, or have they been doing the same one yesterday and today?
So the three scenarios, the environmental variables are the same. That is, they have no information, they have shot detection, or they have the facial recognition giving a description. But the way these play out is totally, it's dynamic. So the AI that's driving the shooter, again, he has those behaviors, aggressive, passive, evasive. He dynamically makes that decision as the simulation is running. So if we ran one of these same scenarios 3 or 4 times, when he starts shooting, where he goes, how he responds to the officers, where he runs if he sees them, those are all different. So we're trying to control as many variables as we can, but it has to be realistic. We can't just have them learn the pattern.
Right.
That's what we want to avoid. But that's why we also have to run multiple scenarios, the same scenario over and over again, so that we actually get the data when the shooter is aggressive, when he's defensive, when he runs this way, when he runs that way.
You mentioned that both these officers are alert instructors.
Yeah.
Do y'all have any kind of working relationship with
I've
them?
talked to Alert about they're aware of it, they were invited, but they have,
They chose not to?
chose not to come. But I did have a Zoom conference with them about a couple of months ago about what we were up to. So I think it's important to work with them. I think it's very important. But getting back to what Daniel was talking about, I think that it's important to know that the pilot itself will be coordinated with Houston Community College, but we want participation by all potential stakeholders in the area from Dallas and Houston. So we represent and pressure test everything as much as possible. So by the time the pilot's over, we'll have a capability available to provide to Dallas and Houston as a service. So you can set up scenarios depending on complexity and various price costs, but set up scenarios that will look at factors you care about, examine the factors analytically with human beings participating, and then generate data to make decisions on what to do or what to buy, and then use the same environment for rehearsal. So it's very important that you understand that it's experimentation and rehearsal. Experiment with things that you think will make a difference and then rehearse against it. And there may be new ideas and new thoughts for mitigation that we could represent in the virtual environment that you're not sure about, that may cost a lot of money. We can generate enough scenarios and enough data to give you a significant argument that something should be purchased or not.
We have a question from the back.
So I know that this is still new,
Yeah.
but do they plan on adding any type of communications?
Yes.
Because when you have to communicate with a command post and you have to
Yes.
communicate with dispatch and things like that. And what you practice is what you do.
Right.
And so if you're not practicing command, you're not doing it.
Yeah, I can speak to that. As Jim mentioned earlier, the question was, how are we going to handle communication when this thing gets bigger? The engine, this is built on game engine technology. This is a very solved problem. We can have up to 100 human users. The goal ultimately is that they won't be co-located. People will have different roles. There is off-the-shelf technology we'll be pulling to allow the VR people to communicate with each other. We can close off networks of communication. We can open up networks where people can listen in, or we have complete configurability over those channels. But the headsets have microphones. Microphones are inexpensive and easily sourceable. So this is just a checkbox, really.
Right,
That
so-
we flick the switch on, put mics in place, and that will
So we
work.
can represent proximity audio between the operators and also radio. We can represent that. And also will eventually represent interaction with the non-player characters. The people that are enabled by AI, they'll be able to talk to you. You've seen some of the AI figures out there in the world right now. They seem pretty realistic.
Yes.
So, and one of the things we're going to look at is what we call a reality quotient. How many operators do you need to make the scenario realistic when we do these experiments? You may want to have X number of operators to make it realistic. The rest can be non-player characters. But then once you find out answer some of the questions about new protocols or new technologies, then you can use that environment for rehearsal. Rehearse against new procedures, rehearse against new technologies, and make this part of your regular rehearsal process. It would augment what you're currently doing, but maybe with more precision. And I want to also say that this was developed over about a month and a half. There's a lot more detail and realism for the figures that will happen when we do the pilot and when we do the service itself. But this is kind of a glimpse into what the pilot will look like, and the pilot would be a glimpse into what the overall service would be looking like starting sometime in the summer of this year.
So one more question. So I know that they use the gloves to enact a lot of things. Will there ever be anything like you see in video games to where they have a rifle that you can interact with or a handgun that you can interact with?
I can speak to that. The answer is yes. The platform we've built is hardware agnostic. So what we could have theoretically is 10 people in full dive using the gloves. We could have 10 people just using headsets and controllers. We can also have people in the Omni, in the treadmill, with rifles which are fully tracked. So right now, if you go in there, you can see that their hands are tracked. So the question for the folks at home again is, what does the hardware stack look like? What are we compatible with? So yes, the military, even at IDSEC this year, lots of technology off the shelf that we can pull to track things like rifles, realistic weapons, CO2 cartridges that give realistic feedback too. So because that's tracked in the real world, we can track it in the simulation. So there's really no limit to what hardware we can integrate and it's all interoperable with each other. We could have somebody not in the Omni, but with a rifle. We can have, again, we can go full dive. We can have pistols which have trackers on them that are holstered, and the officers will draw in VR. They'll be able to see it. The sights will be where the sights are, and then we can control all of those factors.
So in this case,
What you need.
they asked me when we were playing the demo, should we have a physical weapon or should we have a virtual weapon? So I said, let's do a virtual weapon. But as Daniel said, we can have physical weapons that augment the VR environment. It just depends. But as the VR environment's progressing, eventually everything can be virtual. And the feeling of touch and haptics is a technology that's kind of bleeding edge and it's still under development. But the technologies, that feeling of touch is very important, as I'm sure you know in law enforcement. Being able to touch the individual, grab them, hold them, cuff them. That's why we're emphasizing haptics. But eventually we'll be able to, as the technology progresses, we should be able to do everything virtually. We're not quite there yet. So we're showing some capabilities here that you saw in the movie Ready Player One. It was set in the year 2050. We're showing how it might happen today.
And I'll go back to your question on communication. There's no limit, like you said, the capability of anything that can be put into this. You're seeing the baby steps of something being built that was built in a month and a half. And by the time we get to the pilot, you're going to see completely different. What those officers are seeing, if you put it on, you're there. And you put one of those suits on, and those officers will tell you they're exhausted. It's shocking them. It's doing anything that shooter demonstrates or does. Your heart rate, their eyes, everything that's going on in that is taking data. And that's one thing that has to be pulled. What is going on in that officer? Where is he feeling? What is he feeling going through the scenario? These are very PG scenarios because we had some folks here that we just know that it's just not going to be, for our law enforcement group, it's nothing for us. But for our groups that are not used to that, we had some that couldn't even come into this room to see that. And so you have to understand, we have a different audience for everybody that comes here, and we have 6 of these today. And so it has to be this base model until we keep moving up and build this into a better. We know what we need to. We know where we need to be, but we're getting here first, giving you the demo, letting you understand what's being built for you, and what's being built around the country for law enforcement to be better, at what they're going to do when they come in. I know James asked, well, can you put this into a school that these officers are working in? Absolutely. And can you put it into a training where an officer's doing a traffic stop? Absolutely. You can do, there's no limitation on what you want to do with this, and they can do it before it ever happens. And just like a lot of the training that law enforcement's been doing for years, or reality-based training, or any of our RBT, any of the stuff that we do with that is very similar. But this gives you an environment where you don't need a shoot house, where you don't need a giant location to go. You can have a very small place, a very limited for folks to go to and send it to a regional or whatever, and then they go through this training and they're like, man, I just trained in my school and I wasn't even there. And so think about that is where it's at right there, where they can have that training available, get to this, and have something to stop it before it got there. And being very familiar with their surroundings and having that muscle memory. Where's that door? Where's that cafeteria? Where's that library? Then they can go right to it. Most of them are going to know that already because they're working in the schools. But you're also going to have officers responding that have no idea what they're walking into. And so this is where this can fix that.
You want to talk to the dashboard, Daniel?
Yeah. Okay. So good.
Thanks a lot.
The simulation is collecting some data for this version. The full version collects biometrics. There's a lot of biometrics, systolic, skin temperature. We have eye tracking, so we can, by mapping some of those data points together, We can actually approximate, we can estimate what the officer stress level is, what their comfort is. But for this one, we're just taking some low-level metrics and showing this mapped in a few simple ways. The longest scenario time, completion time, average times across the sessions that we've run today, how many shots were fired by the shooter, how many victims, and how many times the officers themselves were injured. There've been none of those today, so that's good. But this is, a kind of a snapshot of some of the data you get. Now, what's going into these boxes really is that you are subject matter experts. You know what you want to see. So anything can go here. There's really no limit. I want to speak to something that has been touched on, but I'm in the software side. Our background is video games. I've noticed that what happens is people turn on their Xboxes and they play, these games, and they look amazing, and there's so much stuff you can do, and it's incredible. And then they put the game away, and then they go to work, and this kind of barrier appears, and they're like, that's video games, that's magic, we can't have that. You can have that. There's no magic about this. If you've seen it, and you can imagine it, and if you've played it in COD, or if you've seen it in anything at all, we can implement it. Software has very few limitations that the real world has. So whatever data you can imagine you want to capture, worst case we can't capture it, but the chances are very good that we can.
So what we're going to be doing in the pilot is to have participation of the key stakeholders in Dallas and Houston participate in planning and executing it. Operational participation of your operators and participation of your organizations in building the scenarios and executing the things. So once again, what we're doing in the demo is getting your input from the demo, but more so when we do the pilot, you'll be participating in planning it. So when the pilot's done and we're ready to go to market, we'll have something that works for you. We want to make sure that you're helping us make the sausage.
If there are no other questions, we'll let you guys loose. If you want to take any questions with us offline, come and speak to us.
They could go back there too to take.
Yeah, if you want to go and
you
take
want to
a
look back at the
hardware,
operators where the equipment
check
is.
it out.
Talk to.
Thank you.
Apparently I misspoke earlier, these versions of the test.